What led to the sun-centered model of the universe being the prevailing model? The nickname for that shift in thinking is the Copernican revolution. Anytime that there is going to be a change in thinking, that change needs to be precipitated by something. There needs to be some evidence, some need to change, and the model, the prevailing model, in order for it to be evaluated as a good model, needs to explain things well. So here we've got a picture of Mars. So this reddish dot here is Mars, taken every few nights from June to November. Notice from June to July 30th, Mars is moving one way with respect to the background stars. Then for a couple months, it moves backwards with respect to the background stars, and then in the original direction. This is known as retrograde motion. And this retrograde motion is something that needs to be explained by any model of the universe. And by the way, I'll probably interchange the words universe and solar system. In this context, they mean the same thing. So that needs to be explained in some way. The ancient Greeks, Ptolemy, explained it this way. They, of course, thought that the Earth, most of them thought the Earth was at the center of the universe, and the planets went around. Well, for that observation that we just saw when Mars appears to go backwards, they explained that by saying that the planet is actually on a loop, and that in order for you to observe the planet going backwards, it's actually doing this sort of curlicue line here. So that is the retrograde motion loop. That's not a very good explanation in terms of simplicity, because first off, what would cause the planet to do this? Well, we could say it's orbiting, but if you look, there's a dot right here that's under my highlighter, but that dot doesn't represent anything physical. So this planet would be going around nothing in this little circle, and of course the big circle would be going around the Earth. That's kind of a complicated model. A better model is that both the Earth and that other object, Mars in this case, are orbiting the same thing, the Sun, and this backwards motion occurs when the Earth, the inner object, passes the outer object. That outer object appears to be going backwards. You notice the same thing when you're driving along the highway and you pass a slower vehicle. It looks like that vehicle is going backwards. Or if you're taking a train trip, oftentimes trains, they're pretty smooth, the tracks are well made. You might kind of doze off a little bit, and then you wake up and you look out the window and you think, wait a minute, are we moving or is the outside moving? Because it appears that the outside is moving backwards. That is a better explanation of retrograde motion than the Ptolemaic or the Earth-centered view. Another piece of evidence here came initially from Tycho Brahe, who was a great observational astronomer, and when he passed away, he bequeathed all of his observations to Kepler, who was a great analytical astronomer. He took that information and noticed some patterns, and one of those patterns was that the best explanation for Tycho Brahe's observations was that planetary orbits were elliptical, and those ellipses, at one focus of the ellipse was the Sun. So this is a highly exaggerated ellipse. No planetary orbits are this exaggerated. A lot of comet orbits are this exaggerated, where they get close to the Sun and really far away from the Sun. He also noticed that when objects are closer to the Sun, they're moving faster, and when they're farther away, they're moving slower. This rule you may remember if you've heard this before, if you read it. A planet sweeps out equal areas in equal times. So if these light blue wedges were pizza slices, each of these pizza slices would be the same size. So any explanation of the solar system needs to address this, and this notion of the observation of the planets. Kepler said, okay, the best explanation is planets move in elliptical orbits with the Sun at one focus. And one thing that this brings about is that the innermost planets are moving a lot faster. So Mercury is moving the fastest of all the planets, and this only shows the naked eye planets. Uranus and Neptune would be moving even slower. And they're moving faster, the innermost planets are moving faster, not just because they make a smaller orbit around the sun. Essentially, they're on the inside lane of the track. And if you're on the inside lane, you're going to get around the track faster. But Mercury is actually moving a lot faster. So you can see this is the speed. So it's going about 50 kilometers per second compared to Saturn, which is about 10 kilometers per second. Again, any description of the solar system, any explanation of how the solar system works needs to incorporate that. This is one part of the Copernican revolution. This is Galileo, and Galileo observed a few things that led to the Copernican revolution. One was he observed that Venus has phases. So if you look at Venus throughout the year or throughout its orbital cycle, sometimes you'll see a fully lit Venus. Sometimes you'll see a gibbous Venus. These are like moon phases. Sometimes you'll see a quarter, sometimes you'll see a crescent. And the pattern of those phases is best explained by Venus going around the sun and the sun illuminating Venus from a different perspective as viewed from the Earth. The old view was the Ptolemaic view. That was that the sun went around the Earth. The sun still illuminated the planets, but in this case, you're never actually going to get a full Venus, because Venus has to be on the opposite side of the sun as the Earth in order for it to be full. Galileo observed gibbous and full phases of Venus, so that must mean that Venus can't be following this orbital pattern. Another thing he observed were so-called imperfections in the moon. If you look at the moon, you'll notice that in the bright part of the moon, there are some dark sections, and in the dark part of the moon, there are some light sections. This implies that the moon is not a perfectly smooth ball, and the prevailing view was that the heavens were perfect. So how can the heavens be perfect if the moon, which is in the heavens, the celestial realm, has these imperfections such that some parts can be down low and dark, some parts can be higher and be illuminated by the sun. Here is a copy of Galileo's notes of the moons of Jupiter. If everything orbited the Earth, how could this planet here, Jupiter, have these things orbiting around it? So Jupiter's moons were another knock against the Earth-centered view. So that's it. Lots of pieces of evidence, and perhaps this is the one that I should leave you with because this is a copy of Galileo's own handwriting. So anytime somebody asks you, well, what's the evidence you've got some sort of Earth-centered person, they want to sleep for 500 years, they wake up, they say, so what's the evidence that the Earth goes around the sun, that the best explanation is the sun is at the center of the solar system? What I just went over would be some great points to go over with this person who slept for 500 years.